So here in 8.7, we're going to be taking a look at nonlinear systems of equations. So we looked in 8.1 at linear systems of equations. So now we're going to go ahead and move into what we call the nonlinear. Two objectives. We're going to be solving nonlinear systems of equations graphically. So we're going to be doing things with like parabolas, circles, lines. Then also we're going to be doing nonlinear systems algebraically, and that's mainly going to be substitution, if you remember that back from 8.1. So we're going to jump in and go ahead and look at this graphically. So when we do this, they've given us two equations, and I'll label this equation 1 and equation 2 over here, and that way you can reference those. But what we want to do is we want to look at equation 1, and what you're going to be asked to do is you want to identify some of the key things in equation 1. If you look here, equation 1 ends up being linear. Equation 2 looks like a circle. If you think back to our circle section in, what is that, 3.6 or so. So you can see the first question, what type of equation is the first equation? And so we would call that linear. And once we identify that it's linear, that's what you would select on your homework assignment. Then what they're going to do is they're going to ask you a couple questions. They're going to say, well, what's the slope of this line? And what's the y-intercept? So the best thing to do is maybe put this in, instead of standard form, let's put it in slope-intercept form. So we'll rearrange this by simply subtracting x from both sides. And in doing so, we put this in slope-intercept form. And that will allow us to identify the slope. Our slope is going to be the mx plus b. So what we have here is -1 is going to be our slope. And then our b value ends up being our y-intercept is going to be right here. So it's +2. Now remember, the y-intercept is a point. That is what is expected of you to write is as an ordered pair. So our slope is simply going to be -1. And our y-intercept is the ordered pair 0, 2. And so we would type that in, and what Hawks would do on the computer is it would graph it for you, and then on the test we would graph it ourselves. Then they're going to ask you what in the world the second equation is, and you can see that it's a circle. It's a circle where our h and k are both 0. So if you remember our standard form for a circle, x minus h squared plus y minus k squared equals r squared, if you remember that. And so as you look here, you can notice that h and k, there are no constants here. So that just simply means that the center of my circle is at the origin, and then my radius r squared, well, if r squared is 4, that means my radius is 2. So you can guess what kind of things they're going to ask you about on the second one. So once we select that it's a circle, then they're going to ask us two questions. They're going to say, what is the center of the circle, and then what is the radius? And we just identified that. But in this case, we're looking for that hk. Remember, those are counterintuitive. So if we did have values that were up here, we would look in the opposite of what our eyes see. But what we would have here for our center is simply going to be 0, 0, and then our radius ends up being 4. So we'd put 0, 0, and the radius is 4. And we would graph that, or let Hawks graph it. And what you'll notice is we get a sort of a graph that looks like this. We have a line and a circle. And what we're looking for is anytime you're solving a system of equations graphically, we're looking for where these two items would intersect, if they do. And so if you take a look here, it looks like they intersect right there at that point and at this point. And just like when we learned in Algebra 1, when we graph these linear equations, there's this human error. These better cross at really nice spots, otherwise we will not be able to identify what they are. And so what we have here is it looks like 1, 2. So this point right here looks like 2, 0. And this point right here looks like 0, 2. Now, we probably want to verify and make sure that these are actual solutions here. So what we want to do is take 0, 2, and we would come back into the original problems. Those two, my line and circle. And if we plug in 0 and 2 for x and y, and then 2, 0 for x and y, you'll notice that it works in both. Feel really good about those two answers. So our solutions for this one, then verify your solutions. Our solutions ends up being the point 0, 2 and the point 2, 0. Would be our two solutions for this one. And that would be a graphical approach. So let's take a look at another, a little different one this time. If you look at the second equation, it's really the same. I didn't change that up. So the second one's going to be the same as what we just did. It's going to be a circle. And then what we're going to have here is we're going to end up having the radius in the center. And so we will identify those right now. And so the center we identified as 0, 0. And then the radius on this one was 2 again. So we would put in our 0, 0, and the radius is 2, and we'd have that same circle that we had last time. And so now what we want to do is identify what the equation is right above that. Now, what hopefully gives it away is that we have this y squared. And so squareds, the squareds indicate that we probably, especially if one variable has it, but the other one doesn't, we're dealing with some type of parabola. Now, we're not used to the y squared. We're used to x being squared. And so when we had something like y equals x squared plus 2, we knew this was a parabola. And then we would use a transformation or t-chart or something to get that graph kind of thing. And so we identified this as being a parabola. So when one variable is squared and the other one is not, it's a degree of 1, we're talking about some type of parabola. So here what we have is the same situation. If I get x by itself, just real quickly, let's get y squared minus 2. Then what I end up having is I end up having a parabola. But it won't be a U-shaped or an N-shaped like we have when x is squared. What we end up having is like a C-shaped or a backwards C-shaped. And so we still have a parabola, but it's going to be on its side. And we can sort of use transformations, but it's going to be a little tougher because you almost have to tilt your head to the right. And because this ends up being a vertical shift for us, and we look at that, but vertical shifts with parabolas on their sides actually moves them horizontally or right or left. So if you turn your head a little bit to the right, you can see whatever parabola we have, we're going to be taking it down, which is actually, if we straighten our heads, it's actually going to be going to the left. Another thing you can do is simply just do a t-chart and plug in a few points to identify what that's going to look like. So right now, y squared, where x has a degree of 1, is going to be a parabola on its side. The other thing they're going to ask us to do for a parabola, though, is they're going to ask us to identify some key points. So they're going to ask us the vertex and then the concavity. So we're going to either say concave left or concave right on one like this one instead of up or down. Now you will have some that are up and down as well, but I wanted to show you a parabola on its side. The vertex, we remember the formula, the opposite of b over 2a. That will work here, but it finds the y value of this vertex instead of the x value. So in other words, if I look at this and I say, well, my a value is 1, my b value is 0, and my c is -2. So if I do the opposite of 0, all over 2 times a. And so I get something like this. I end up getting 0, but that's not the x value of this vertex, it's the y value, because my variables have changed responsibilities. Then if I plug the 0 back in, I get -2. And so my vertex on this one is simply -2, 0. And that's going to make sense. We have that shift to the left, we said. And so you can identify that right here. So you see the blue parabola went from the origin over left 2. Okay, so -2, 0, that's my vertex. And you can see we can either use a t-chart or you can identify that here the a value is positive. So positive when it comes to a parabola on its side means it's a more of a C shape rather than a backwards C shape. And so in this case our concavity would be right. And we've graphed these two things. And what we'll notice here is here's a great example of where we actually get 3 points. Where our solutions are. Okay? As you look at these, though, we want to be very careful because what we have here is we have x is 1, but notice that we actually have 2 different y values. And those y values don't assume necessarily that that thing's going to be 2. It's actually slightly less than 2. So the x value is going to be one that we can eyeball. So I definitely have 1, and there's another one with a 1. We got to figure out the y value. Then the third point is this one over here. Well, that's our vertex, so that's -2, 0. So that one's not too bad. But we really need to find these y values. Okay, just think to yourself, if I know the x value, what can I do to find a y value? And that goes back to a substitution. And so we can go into either one of these two. So if I know the x is 1, then plugging this in, I get 1 plus 2 equals 3. So y squared equals 3. I'll put that up here. Y squared equals 3. So notice that's not 2. It's somewhere between 1 and 2. So if I, got a little ahead of myself, excuse me. It's 3. And so what we have now is if we square root both sides, just don't forget your plus or minus sign, then what we end up having now is the square root of 3 and negative square root of 3. And those would end up being my 2 points that I'm looking for. So we end up getting those 3 solutions. So be very careful on those. Don't assume too much. The x values should be hopefully obvious. The y values you may have to spend time finding. Okay, here's one just pulled straight off of Hawk, so you can sort of get the idea. They're going to ask you multiple steps. So you can see here, step 1, identify the graph of the first equation. Okay, the graph of the first equation is what? So we look at this this graph right here, this equation at the very first right there, and we identify what that is. Now, if I add the 1 to this side, I think that will make it look a lot easier for you, or a lot more obvious. So what we end up having here is this is a quadratic. See, notice that even though x isn't squared now, if I would FOIL, I would get an x squared, and y has a degree of 1. It also, hopefully what you recognize is that this thing is in what we call vertex form. So we talked about that when we went through our quadratics. And so we can find our vertex very easily. All we have to do is we have to identify the h and the k. And the h is counterintuitive, and so I know that my vertex is going to be -2 and +1. And then my a value is 1/2. That tells me my concavity. That's going to be really nice. And so what we would do is we come down here and we would click on parabola. Okay. Now again, most of the ones you're going to get are going to be straight line, circle, and parabola. Very rarely are we going to see ellipse and hyperbola. So those are more of trying to give you just another choice. So don't spend a lot of time debating on those two. It's probably going to be one of those three. So that would be step 1. As we finish step 1, they're going to then pop up a box that says, okay, now that you've picked a parabola, what is the vertex? And so when it's in vertex form, man, that makes our lives a lot easier. We put that in. Which way does it open? This is a traditional parabola, so that opens up or down. If the A is positive, that means it opens upward. And so we would label those things. And then Hawks will end up graphing it for you, and then they're going to ask you the number of solutions. Now, a really nice thing to do is, if you do a little sketch, we can actually do this without having the whole graph. If we go to -2, and we go to +1, and we put it up, then what we have is we have our concavity is upwards. So even though I'm not graphing the exact parabola, I'm just getting a little sketch of it. So if you notice here, what we're asking, it says select the number of solutions to the nonlinear system in the boxes provided. And as you see this, what we have now is we have no real solutions for this one right here. And so the only solutions we would get would be imaginary, which right now we're not going to be considering those. And so we would end up getting no solutions for something like that. It doesn't cross the x-axis at all. And so that's what we'd have for at least the first one, would be none. Now, typically what they'll end up doing is, instead of us answering 0, what we're going to do is we're actually going to graph the second one. So this bottom box down here that I have, this actually is the last thing we do. What they're going to do next is they're going to ask you the same question about the second one. So they'll say, okay, well, what in the world? Step 2 is, okay, identify the graph of the second equation. So we look and we say, well, if I move that 1, it's a lot like that first one. So it's a parabola as well. We would click here. Another one of those boxes would show up, and you would end up going, my h is counterintuitive. My k is exactly what I see. My a value is positive, so that is also upwards as well. So if I go to -2, -1, then what you'll notice here is that I have another sort of U-shaped. And so as we graph these, the first one's actually going to be much flatter. It's hard to tell that, but I'll sort of put that, and we can do a T-chart here in just a moment, and I'll show you that. And then the second one's going to do something like this. It's going to be a little bit skinnier. And what you'll notice is here's where that final step comes in, is that we should end up getting, it looks like 2. And so we would go ahead and click on 2, and then what they're going to ask you to do is they're going to ask you to identify what those two values are. And then you would look at your graph and identify those. Okay? Now, so since I don't have the graph necessarily up here, when we graph these, a simple T-chart would work as well. And so plugging things around your vertex would be good to help you get a graph. But again, on Hawks, they're going to go and graph it for you. And so there's not a lot there. You just have to find what X values are there and then plug those back in to find your Y values, especially if you're unsure if the Y value is exact, just like that previous problem. Now, let's move away from the graphing side of it, because really the majority of the ones you're going to get is going to involve algebraic ones. So I want to spend most of our time here and make sure we get this. So if you notice here, I gave you a parabola. We're saying one like this, a parabola on its side, and then a circle. So if we go back to this one, what we have is we have this red and blue parabola and red circle. The graph alone, it really isn't clear where the intersections are. Instead of graphing, we must resort to other methods. And so in something like this one, where it's a little like, I can't tell where those are crossing, is it once, is it twice in each of the, do I get 4 solutions, do I get 2 solutions? It's really tough to tell. So that's sort of the air that graph has for us, is that human air. So what we want to do is we want to resort to more of an algebraic approach. So what we're going to end up using is substitution, and you can see there. And I've really written this whole problem out, so I'm going to go fairly quickly here, but you can hopefully follow step by step. So here's our system of nonlinear equations. To use substitution, what we want to do is we want to substitute any equivalent value. So it doesn't have to be just x. It doesn't have to be just y. We can isolate, let's say, y squared. If you take a look here, y squared is already isolated. So I could substitute in x plus 4 down here for that x squared. That is a possibility. So you're not always having to substitute in for just x or just y. It could be substituting for y squared. So let me show you that real quick. Just as another example, rather than substituting down here, if what I do is I subtract x squared from both sides. Okay, so down here, that x squared goes away. Then what I have is I have y squared equals 4 minus x squared. So wherever I see y squared, like right above here, I can replace it with 4 minus x squared. And that's what I did over here. So I've isolated and I got the y squared. So now what I can do is set x plus 4 and 4 minus x squared equal to each other. Now hopefully what you identify now is that we have a quadratic. Anytime you have a quadratic, we set equal to 0, and we look to factor or quadratic formula. And so the 4's end up canceling. And then I moved that x squared over by adding that x squared here, and then I did a GCF and set both these equal to 0, and I got 0 and negative 1 as my x's. So now we need to investigate how do we find our y values. And so once we know what those x's are, we're going to go and back substitute these into the original problems. And it can fit into either one. It doesn't have to be just the first or the second. Either one would work. They give you the exact same value. So you notice I substituted in negative 1 and I substituted in 0. So then I went ahead and solved. And you notice here when I plugged in negative 1, what I end up getting is I got positive and negative square root of 3. So I got here and I got here. So those are the two answers I got there. Now, when I plugged in 0, what you'll notice here is that I got two results for my y. So I plugged in, I did the square root of both sides. Don't forget your plus or minus sign. And then what we get is we get y is 2 and negative 2. So when we plug in 0, we get two values. So what you'll notice here is we actually get 4 answers to this one single problem. So if we go back to the graph, it's really hard to tell, but if we could zoom in, this thing crosses actually twice. The red and blue up here, and then it crosses twice down here as well. And this verifies that it would end up having 4 solutions at the bottom of the page. Okay, let's take a look at another one, something like this. So if we look at the first problem, that's your ellipse, okay? And so even though graphically we're not going to be dealing with those, we may algebraically. So not a big deal, but you can sort of see the red ones in the ellipse. That division of 9 stretches it horizontally. There is no vertical stretch on this one because there's nothing with the y. But all that, let's put that aside. If you look at the bottom one, what we have is we have a parabola on its side again because we have y squared and x has a degree of 1. And so graphing this system, really what I want to get across to you, and why I showed you this, is I want to show you that it really looks like there's 2 solutions. But there could be hidden, or what we call imaginary solutions here. So you can only find the real solutions graphically. So we want to solve this algebraically so we don't just find the real 2 solutions, but we actually can find the 2 imaginary solutions. So there's going to be technically 4 solutions here. So let's look and see how that works. So what I did is I took the ellipse first, and I took the parabola second. So here's our ellipse, here's our parabola. And then what I want to do is use some type of substitution. So notice with the parabola, I know what y squared equals, x plus 2. So I'm going to use a substitution. I'm going to come over here where there's a y squared. And I'm going to say, I know what y squared equals, x plus 2. So we're going to use a substitution in and make that x plus 2. So you can see that right here on this second line, is that I've made x plus 2 replace that y squared. This should allow me now to do some arithmetic and to simplify this a little bit down so that I can figure out what kind of problem I have. Looks like it's probably going to be a quadratic by the end of it. But what I did here is I always set polynomials equal to 0. And so I moved the 1 over by subtracting 1, and I got 1. At that point, I'm just like you. If I can avoid fractions, I'm going to. And so I'm going to multiply every single term by 9. That eliminates my 9 here. It gives me a 9x. It gives me a 9. And then 0 times 9 is still 0. Now it allows me to FOIL and combine like terms. And I'll do that on the next slide. So once I FOIL that, I'll go back so you guys can see it again. I end up getting x squared plus 2x plus 1 plus 9x plus 9. And so combining like terms, that's where I got the 11x, and then I end up getting 10. Okay, so let's go back to that page. So that's where I got the x squared plus 11x plus 10. Should be factorable. If not, use the quadratic formula, but this one's fine. We can factor it to 10 and 1. And so we get negative 10 and negative 1 are my x values. Okay, so now what we want to do is find the y values. And so we're going to end up plugging in negative 1 and negative 10 back into one of those two equations so we can find our y values. And so I'm going to plug it into the more easier of the two. So I'm going to plug it into parabola. And so I'm going to plug negative 10 in, and I'm going to plug in negative 1, and let's see what we get. So let's go with the negative 10. We'll get our imaginaries first. So negative 10 plus 2 is negative 8. Then square root both sides. Don't forget your plus or minus sign. And then I can take an I, and if you recall, we can break 8 down and take a 2 out and leave a 2 behind. So I took not just an I out, but I took a 2 out with it. I didn't forget my plus or minus sign, then I had a 2 left over. So when I plugged in negative 10, I got two answers. I got a positive 2i square roots of 2, and I got a negative 2i square roots of 2. So those are my imaginary, sort of the ones that are we didn't see graphically. Now these are going to be the two that we saw graphically, the two real ones. So when I square root both sides, don't forget your plus or minus, we get 1. So when I plug in negative 1, I got 1, and I also got negative 1. And those are my two values. So look at the bottom of the screen. We have all four solutions, not just the two real ones that we can get graphically, but the two imaginary ones that we have to achieve algebraically. Okay, let's look at just a few examples here, and we'll call it good. And so we're looking at this first one here. It says solve the following nonlinear system algebraically. So we're looking for a substitution. And this one's set up really nice because look, y is by itself right here. So I could take the x squared minus 19 and actually just substitute in for that y into the second equation. So let's do that. So I got 8x plus not y anymore, and I would encourage you to use bubbles. And the reason is if this is a minus sign, we'd have to distribute. So keep that sort of in your mind as well. And that's going to equal negative 35. So again, what I've done is I've taken the y value in the first equation and substituted in for the y into the second. Looks like a quadratic again. And so I clean it up a little bit. I'm going to have to move that negative 35 over by adding 35. But I should be ready to hopefully factor, if not quadratic formula. And so x squared plus 8x. And when I add these two, I end up getting 16 equals 0. And man, this does factor really nicely. And we end up getting a double root. And so x is negative 4. Okay, so we found our x value of negative 4. So we know it's negative 4. Let's see how many y values. So we got to answer this question, but we're going to do it last actually. What I recommend is solving it on your scratch paper and then selecting which one. They'll pop up the boxes, then you type it in. Okay, so it's hard to select how many you're going to get before you find them. So if we plug in negative 4, let's go ahead and just plug it in the bottom one. So 8 times negative 4 plus y equals negative 35. So I end up getting negative 32 plus y equals negative 35. And you notice if I add 32 to both sides, I end up getting y equals negative 3. So I end up getting the value negative 4, negative 3. Okay. Let's verify real quick just to make sure it matches up with the top since we haven't done that too much. So if I plug in negative 4 here, I end up getting 16 minus 19 equals y, and y is negative 3. So we end up getting just one solution, and it ends up being negative 4, negative 3. Right. Looking at the next example here, you can see we have the first one's going to not quite be a circle kind of thing, but it's pretty close. The second one is going to be a similar type of thing, not quite a circle. We're looking at more of a different type. But all we need to worry about is our solving this algebraically, so substitution. So to me, when I look at this, I really feel like I can probably substitute something in for y squared. So maybe if I get this y squared alone, I can use that substitution into the second equation. So if I subtract 3x squared, then that allows me to write this with y squared isolated. And now what I can do is take 36 minus 3x squared and substitute that into the second equation. So we end up getting this for my new second equation. So instead of y squared, I end up having 36, I'm going to put it in bubbles just to remind us, okay, equals 21. And now we go ahead and solve. And I've got to do some arithmetic here, so I'll do it quickly. But x squared plus 2x plus 1, I do need to distribute that 3. So I get 3x squared plus 6x plus 3. Okay, over here what I have is I can really just drop the parentheses since we're adding. And let's go ahead and now clean everything up. So notice my x squareds go away. That's nice. And I have 6x plus 39 equals 21. And this is just a two-step equation. So let's go ahead and do those two steps. And I get 6x equals negative 18 and x equals negative 3. So we got our x, negative 3. And now we got to find our y. So we're going to use a back substitution. Again, I'm going to try to pick the easier of the two to plug it back into, so I'm going to pick equation 1. And so I'm going to have 3 negative 3 squared plus y squared equals 36. And I end up getting 27 here. Negative 3 squared is 9 times 3 is 27. Y squared equals 36. We're going to get two answers here. So y squared equals 9. Square root both sides. Don't forget that plus or minus sign. We end up getting 3. So we're going to square root both sides. That's where I got the 3 from. Don't forget that plus or minus. So for this 1x, this negative 3, I actually get two answers. I end up getting positive 3 and negative 3 as my two answers. The nice thing about these kind of problems is any systems you can check and see if you're right by simply plugging them back in. But what we do is click on the 2, they pop up 2 boxes, and we'd write in our 2 solutions. Okay. Moving on, let's look at one like this. Very similar. Really, it's fairly identical. So I'm actually going to move on to this very last one just so we can get it in, and we can investigate. You can investigate the prior one on your own if you would like. Okay, this one says use the methods of solving nonlinear systems to solve the following word problems. So we don't have a lot of word problems, but they give you a couple like this. So I wanted to make sure to address it. And what we need to do is write the system of nonlinear equations here. So it says the product, which means multiplication, of 2 positive integers. Okay, so integers are our Gauss scores, so no fractions, no decimals. So the product of 2 of these, and I don't know what 2 they are, but I know is equals 99. So I'm going to be multiplying 2 things. I don't know what they are, so let's call them x and y. But I'm going to multiply those 2 things, and the product should be 99. This is going to be my equation 1. I definitely have 2 variables, so I need 2 equations. So I say, well, let's write equation 2. Let's see where we can get that. Then it says, and their sum. Okay, so that's x and y. Sum means addition, so we're adding x and y. Is equals, and then 20. So what I have here is I'm using x and y, but adding them now. And that sum should equal 20. At this point, we're ready to solve our nonlinear. And so what we want to do is a substitution. Personally, what I'm going to do is I'm going to use the second one and substitute in the first one. So I'm going to get y by itself on the second equation. And I take 20 minus x, and I'm going to end up taking that, excuse my marker here, taking that 20 minus x, and we're going to substitute that in for the y up in the first one. And so we're going to get x times 20 minus x. Now, I hope this somewhat, it's a little similar to when we did optimization problems, where we had a primary and secondary equation. So that may come to your mind. It's very similar to what we're doing here. But we should get a quadratic. Instead of finding the vertex, though, we're actually going to solve it for these problems. So we get 20x minus x squared. That tells me it's a quadratic. Now, I like keeping my a positive. I encourage you to do the same. So we're going to move everything to the right side so I can make that x squared positive. So I get x squared minus 20x plus 99, and that should equal 0. So I added x squared to both sides, and then I subtracted 20x from both sides. And so that's where I came up with this. We looked to factor, and it looks like we can. We should get minus 9, and we should get minus 11, kind of thing. And so you multiply, it gives you 99. If you add them, it gives you negative 20. And so what we have here is that x is 9, and x is positive 11. And so we've got our 2 values, 9 and 11. And now our job is to figure out what the y values are, because it says what are the integers on a problem like this one. And actually, we just found the 2 integers, to be honest with you, because x and y is going to be the same value for both. It could go either way because we don't know which one. X is arbitrary, y is arbitrary. But let's verify. If I plug in 9 for x, let's just choose x real quick. And I said, okay, well, what is y? If I divide by 9, y is 11, right? Okay. So if I plugged in 11 for x and solved for y, then notice what I get for y is 9. So the 2 values I'm talking about here are going to be 9 and 11. and it doesn't matter which order, I just used an arbitrary x and a y. So you can see that I can add those and get 20, I can multiply and get 99. Please make sure on the exam, I know some of these are so basic that you might be able to do them in your head. Please show your work on the exam. So I need to see the setup of each equation and your substitution and then your answers. So that's really what we're learning on this problem, not necessarily just the solution, but the process to get through to the solution. Okay? So that's 8-7, Systems of Nonlinear Equations. I hope it goes well for you.